This is your first tutorial. Okay, and we are going to start with the first number of tutorial because that is the prerequisite and helpful for the next class, that is laser physics. We are going to take in the next lecture. So this is the prerequisite content which is helpful throughout your semester and for the particular subject of physics. But whatever the activities we are going to do in the tutorial part, see, whenever you listen the word tutorial, that means you need to do some activity, right? So it will be equally good if you people have some pen and paper with you, along with you, so that sometimes if something has to be done, then you can do on the paper, right? So you just take out pen and paper. Again, I'm repeating, just take out pen and paper because you people may need to do some activity on the paper. I'm audible proper?
So perfectly
Yes,
audible.
sir.
Yes, sir.
Yes, sir.
Sir.
Okay, perfect, perfect. Okay, and meanwhile, let me give you the brief idea about the tutorial. Why we require tutorial in a subject, right? So the purpose of tutorial is basically to help you design the systematic approach to solve a particular problem, right? So tutorial will guide you if some unknown problem is there in front of you, then what are the steps you need to take in a sequence so that you can get the desired result in limited time. So that is the sole purpose of tutorial, right? We'll see several problem statement in the tutorial number 1, and the tutorial name is fundamentals of physics. Okay, so that is your tutorial number 1. The tutorial name is fundamentals of physics. Okay, and it's very simple. We are just taking the reference of up to 12th class. Okay, so kind of, as I said, it's a kind of prerequisite so that we can proceed further with full capacity to understand the next lecture, which is going on laser physics. Okay, so if all are joined, then let me start with the tutorial. But I hope the terminology of tutorial is very clear to you people. Again, I'm repeating, those who have newly joined, the purpose of tutorial is just to give you an idea how to solve a problem in a proper and systematic manner. है ना? If you are jumping from one step to directly to the third step or fourth step, skipping some middle steps, then it may create the problem in case of certain problems. So tutorial is always having that purpose that you follow a proper sequence and solve and get the desired result in limited time. Otherwise, you will be jumbled from here to, you will be going to jump from one place to the another and another to then. So it is not going to solve the purpose. So be clear about the tutorial. Okay, and the same thing we'll see in our examples, our problem statement of tutorial number 1. So the first problem, I'm going to start the tutorial main content. Tutorial number 1, again I'm repeating, the tutorial name is fundamentals of physics, and I hope you have taken out the page and paper, pen and paper, right? Because you may have to do some activities. So if you are ready with pen and paper, then this is your first problem statement, that is discuss the electromagnetic spectrum in terms of frequency and wavelength. So this is your first problem statement. You need to define the electromagnetic spectrum, or sometimes people are saying is the EM spectrum in terms of frequency and wavelength. Right, so problem statement is very clear. Now see, to cover this, let me talk about in terms of your point of view, right? If I'm saying electromagnetic spectrum, then obviously all the participants, all the students may not know all the 7 components. Even if they are knowing all the 7 components, see, I told you the answer, but first you need to ask by yourself that if the problem is about electromagnetic spectrum, then how many components, how many regions are there in electromagnetic spectrum? So I told you the answer 7, but somehow people are saying someone are saying 7, someone are saying 6, someone are saying 8 also. Not in your class, but when I was taking the offline classes during that time, people are not aware with this. Not, I'm not saying all the people, but some students may say, okay, three number of reasons are 3, number of reasons are 5. It's a random number completely, but the correct answer is 7. And sometimes people are claiming that 8 is also correct, but in 8 is correct only in the case of cosmic rays, because cosmic rays are very high energetic particles. Okay, so that belongs to, I mean, even more than gamma rays. On the top of that you see the cosmic rays, because high energetic particles. But normally if you talk about this electromagnetic spectrum, only 7 component we are completing. Okay, so the first, see again, I'm focusing on the problem statement, that is discuss the electromagnetic spectrum in terms of frequency and wavelength. So whenever you see the word electromagnetic spectrum, now it is very clear. There are 7 components. Now what are the 7? That is our second task. So we need to write down the 7 component. At the beginning, you can write in some random order, no doubt. So if you are ready with pen and paper, then you try to write down all the 7 components, 7 region of electromagnetic spectrum, even though in random order. Okay, so you people of course might be knowing most probably all 7 you must know, but if even though if you're not knowing all 7, then your fellow, your other classmate can help you out in this. Okay, so can anyone, one at least one reason, fine, someone has written all the answers. So you see radio, micro, infrared, visible, uv, x-ray and gamma. So it's very clear, all the 7 components you know at least. Now the next task is, as I said, first task is how many components are there. Second, what are the name of that component. Now the third is, now we need to arrange in a sequence. Okay, now that arranging is also depending on how, either in increasing manner or in decreasing manner. So one has to choose carefully whether they want to represent the scale in increasing order or decreasing order. Okay, so it is up to you. Yes, someone has written, but it is up to you. You decide, you prefer increasing order or decreasing order. So let's say someone is choosing, I hope you people are doing the simultaneous activity in your pen and paper. So suppose someone is choosing the increasing order, someone is choosing the decreasing order. But again, the next task is very important. Increasing or decreasing with respect to what? Frequency or wavelength. Okay. So again, people are, yes, people are selecting. Some people are comfortable with wavelength part. Some people are comfortable with frequency part. Okay. So one need to decide. Again, I will leave this choice to you people. Okay, if you prefer a wavelength, in terms of wavelength you want to write, you write in terms of wavelength, or if you want frequency, then you write in terms of frequency. After deciding the scale, you select the order, increasing or decreasing. But when you are writing down into the paper, okay, or let's say when you are going to write down into the exam copy, so whatever you write, that is correct, but you need to represent in a proper manner. Suppose you are writing in decreasing manner, let's say you are writing in terms of wavelength decreasing, but your scale is not indicating according to that. See, many times if you see, whenever you do some arranging, you are going to put one up arrow or down arrow. So what I have seen in my offline classes is, I do this activity with offline, in offline classes also. And what people are doing is, they are arranging properly, no doubt their answers are correct, but at the time of representing the things, they are putting some wrong arrow. Even though their scale seems to be decreasing, but they are putting the up arrow or something vice versa. So the whole thing is completely wrong, right? So it all matters how you are going to explain it, how you are going to represent it into the exam copy, or let's say in your answer sheet. Agar aapne, if you are writing something, that is correct, but if you are not indicating the proper symbols, then again it depends on the examiner. He or she may consider it as a wrong, because the whole idea, by looking, see, normally we people are looking at the graph and some other stuff in the exam. So if depends on the examiner, they may consider it as a wrong. Okay, so you have to be very clear with this. So try to arrange. You first select. Most people are preferring wavelength side. So either you arrange in terms of wavelength, either increasing or decreasing. That's fine. Okay, and someone has chosen, let's say, increasing wavelength. Okay, that is also correct. But someone is going to prefer decreasing. So I prefer decreasing one usually. So decreasing wavelength, that means on the top of that, the higher wavelength has to be there, and at the bottom, lowest wavelength has to be there. And if I put the arrow, then decreasing, I mean this decreasing, yeah, downside arrow I need to place in that case, so that it clearly reflects it is like wavelength decreasing as far as. So now this part is covered. Let's talk about the general. See, the basic idea is the problem statement says we need to discuss the electromagnetic spectrum. When I say discuss the electromagnetic spectrum, that means I need to define the ranges, not accurately, but approximate range I need to define. Okay, I need to discuss within that range only. So first we always start with the known one, that is visible range. Okay, and visible, you people are familiar. Many people, as I said, someone is going to write down the electromagnetic spectrum in terms of frequency, someone is writing down in terms of wavelength. So it's a suitable that you write both the scales, one side on the frequency, another side on the wavelength. Okay, why I'm saying both the scales? Because many times we are knowing the things in one scale, sometimes we are knowing the other thing in some other scale. For example, if I'm talking about the visible part, then visible range we know in terms of wavelength. Anyone who knows in terms of frequency, that's good. But normally people around, if let's say participant are 58, 57, 58, excluding me. So in that case, around 15 number of participants are preferring to the wavelength side, and they know the wavelength of visible, that is 400 to 700 nanometer. That's perfect. Fine. Now, in case of this wavelength also, the range, the scale has to be very uniform. As I said, whenever you talk about the physics, your units, your scales has to be proper. If any mismatch is there, your answer is wrong in that case. So here people are preferring, let's say, nanometer scale. So that is 400 to 700 nanometer. That's completely fine for the visible light wavelength part. Now coming to this, see, we have the standard scale. Normally this wavelength we are writing in meter, okay, and frequency we are writing in hertz. So this nanometer part we need to convert into the meter side. So I can write it, instead of nanometer, I can write 10 raised to minus 9 meter. I will tell you the reason why I prefer meter scale. Right now we know the reason in nanometer, so we have written down, but we need to convert into the meter. So 400 to 700, 10 raised to into 10 raised to minus 9 meter you can write for that. That is visible, that is the center part. Okay, now you go onto the top, because on the top the higher wavelength will be there. Okay, so apart from visible, you people can unmute yourself. Apart from visible, which reason you know? Already a seven, all seven we have listed down, no doubt. But let's say on the top we know very well it's a radio, right? The wavelength is very high of radio waves, but how much high? That is the second part. Are you clear with that? Yeah, someone has written the answer. But see, my purpose over here is I don't believe in remembering the numbers. My purpose over here is I just want you the rough idea, approximate ranges based on the surrounding activities or surrounding objects. Okay, so see, someone has written the range also. That's perfectly fine. But many times what happens is we people don't know the ranges. Okay, even I also don't know the ranges at this moment. So what I do is I just try to relate with my surroundings, the objects. Okay, for example, visible I know, that's fine, the middle range. Then I know the radio waves, but radio waves, for example, if I don't know the wavelength, then what I can do is I can think of the object where the radio waves are going to be used. So if you see, if you look at carefully around your surroundings, then you might have heard about FM radio. All of you have heard, right? FM radio somewhere, not at this moment but earlier also. So FM radio, if you look at, then there are multiple channels. You might be familiar with that. That is 98.3, okay, then 91.6, 94.3, and something so many on. So what are the frequency of that radio channels? 98.3 megahertz, right? 91.6 megahertz, 94.3 megahertz. Yes, exactly. So in general, if I consider, let's say roughly I take around 100 hertz, 100 megahertz, right? Yeah, someone has written the range also. That's perfect. So roughly if I take 100 megahertz, so I know the radio waves in terms of frequency because of this example, but I need to convert into the wavelength scale because I'm writing down in terms of wavelength. So what I can do is, as I said earlier, some quantities we are knowing in terms of wave, some quantities we are knowing in terms of frequency. So here the radio waves I know in terms of frequency, that is around 100 megahertz. Now this 100 megahertz I can convert into the wavelength. Now depending on this range, 90 to 100 or 108 and something, there may be slight variation, but we are interested in the approximate range. So if you convert into the wavelength side using the formula C equal to nu lambda, where C is the speed of light, nu is the frequency, and lambda is the wavelength, right? Yeah, this formula is very familiar to you people. So using this formula, you can convert the frequency into the wavelength. And if you convert it, you see the answer comes out to be 1 meter to 100 meters somewhere, depending on the frequency you have chosen at the beginning. So it comes around 1 to 100 meters somewhere, or maybe 1000 meters, someone has said in the chat box. So up to 1000 meter you can consider. So by knowing the frequency of radio waves, I convert it into the wavelength. So I know the answer of wavelength, that is 1 meter to 100 meter. But again, if I take some example, right, to keep in mind, okay, 1 to 100 meter is how much? See, physics will be very simple if you are able to imagine the quantity, right? If I'm saying 100 meter, then in your mind immediately it has to click, okay, 100 meter is okay, this much long. If I'm saying 1 meter, that means immediately in your mind it has to be very clear, okay, that I'm talking about this much of length. Let's take an example here itself. Suppose if I say, what will be the height of you? Okay, so aapki height, if I want to know your height in meter, because in feet already you know, no doubt, your height, but if I say in meter, then sometimes it may be difficult to you people, because if you don't know the conversion between the feet and meter. But normally it's very simple. Can anyone provide the answer, their height in the meter? Okay, 1.78 meter. One answer came. Apart from that,
1.75.
1.75, 1.82, 1.74. Yeah, that's correct. That's
1.75.
correct. Okay, that's good. So these are the answers of your height in meter, right? Now, here is the important part. When I asked in the offline classes, which is around 75 to 80 strength. So some of the members, some of the faculty, some of the student side, they said 6 meter. All right. It seems to be very funny. Why? Because no doubt they are thinking correctly, but the unit is wrong. They are saying they want to say 6 feet, but they haven't considered the factor by which they need to convert, and they said 6 meter. So that's how it becomes very large, right? 6 meter is large quite compared to 6 feet. So that depends how you are going to represent your content in proper unit, proper things, right? Okay, so this clear. Now again, let me give you the example. Some of you people may be possible that they don't know the scale, so I let me remind you the scale part, because I'm going to the very basic level, because that is required in my higher lectures part. So I'm giving you the brief idea. Let me start with this basic units. So you people saying, let's say 6 feet something, 5 feet certain inch, right? So 6 feet is there, then 1 feet is equivalent to 30 centimeter. Okay, 1 feet is equivalent to 30 centimeter, and then you can convert it. 1 feet equal to 12 inch, and then you can find out in 1 inch how many centimeters are there. Yeah, approximately you can calculate it out, no doubt. So accordingly you can calculate for each, whether in feet or feet and inch, whatever, you get the numbers in that case. Okay, so this is one aspect. Now, so if I say, coming to the again radio waves, if I say radio waves having the wavelength 1 meter to 100 meter. Okay, so can anyone identify the object which are having this much range, or that are belonging to this range? Human can be one example, because we are coming with between this 1 to 100 meters wavelength, 100-meter size. So can you identify some other objects which are having the same range of size or length? You can consider the height of a building. Yes, building towers, fine. So that height of the buildings also can be covered under this. So these are the examples. Yes, of course, you can take any object you can take which has the size more than 1 meter. Okay. So that will be the example of radio wave. So what I do is I'm not focusing on the range, okay, because I don't remember the numbers and I don't want to remember also. So what I do is I always try to resemble with some known quantities surroundings. Okay, so radio waves, when I talk about radio waves, that means I simply refer to the height of building or height of a human being. That's it. That is clear. Now coming to the next, if I decrease, since I have chosen the scale decreasing wavelength, so on the top radio wave is there. Now if I decrease the scale, okay, that means I am reducing the wavelength. That means less than 1 meter size. So less than 1 meter, that means around 1 centimeter. Okay, so if I consider that scale, so can you identify the object of 1 centimeter in your surroundings? There are so many. You can consider your yes, eraser. Perfect.
Dust particles.
डस्ट पार्टिकल 1 सेंटीमीटर का तो नहीं होता है. Dust particle cannot be a 1 centimeter long, but yeah, pen ants correct. Honeybee even, bottle cap, yes, definitely there are so many answers. Cockroach, perfect, that's great. So these all are the objects are there in your surroundings which are representing to the 1 centimeter scale, and now this 1 centimeter scale is corresponding to the micro range, microwave, right? So on the top, radio wave, higher wavelength, little less, that is microwave. The wavelength is around 1 centimeter, but our scale is in meter, right? So we need to convert the centimeter into the meter part. So that is going to be 10 raised to minus 2 meter. Perfect. As I said in the beginning, many times we know the answer in one scale, 1 unit, but we required the uniformity. So that centimeter scale again we need to convert into the meter side. So that comes out to be 10 raised to minus 2 meter. I hope you are going to note it down. I am repeating once again for radio waves 1 to 100 meter, for microwave 10 raised to minus 2 meter, and I have given you the object also, जो कि आपके ants ले लो या फिर honeybee ले लो, or whatever you can think of within that range. Okay, now coming to the still lower wavelength, even less than 1 centimeter, less than 1 centimeter, let's say around 10 raised to minus 4, 10 raised to minus 5 meter. अगर मैं 100 के फैक्टर से, if I decrease by factor of 100, okay, then yes, someone has said perfect. Hair pin tip, correct. Pen tip, perfect है. All these are the objects which are classifying in this range. Okay, so that belonging to the infrared. Okay, now the infrared is also very clear. Infrared, that means 10 raised to minus 5 to minus 6 meter. That will be the wavelength of infrared. If you want frequency, then you can convert using the formula C equal to nu lambda. That's very simple. Fine. So this is also clear. Now the next lower one is visible. Visible already we know, and we have converted into the proper scale also, 400 to 600 nanometer, and we can convert into the 10 raised to minus 9 scale meter man. Now still going to the lower side, if I decrease further the wavelength, then comes out to be what is the, if I decrease the wavelength, if I decrease the particle size less than 10 raised to minus 6. See, for visible, yes, for visible, the wavelength is 10 raised to minus 6 meter. Okay, because if you consider 400 into 10 raised to minus 9, so that comes out to be around 10 raised to minus 6 range. So that will be visible. But if you go further, UV, perfect. But what may be the object size in that case? Even less than 10 raised to minus 6, not okay, you consider as a nano, but fine, 10 raised to minus 8 to 10 raised to minus 9, okay, that's fine, nanoparticle orange, yes. So that nanoparticle, you see, that will be your object now. So you don't need to remember the range of ultraviolet UV, you just need to remember this nanoparticle, right? Nanoparticle, that means 10 raised to minus 9 meter, and that will be the wavelength of UV. That's it. If you want to convert into the frequency, you can convert it down. Someone is saying molecule, so molecule is also the same size. Yes, either you can remember with the nanoparticle or you can remember with the, yes, molecule, bacteria. Fine, that is perfectly fine. You can go with that. Okay, somewhere bacteria comes around in the range of visible, and molecule maybe in case of UV. So that is what you do. This is clear. Then the next one is even less wavelength. Yani if you reduce further, yani 10 raised to minus 8 to 10 raised to minus 10. Yes, 10 raised to minus 10 is of X-ray. And if you compare with known object, this 10 raised to minus 10 meter is very famous. You have heard it. Yes, it is the radius of atom, right? 10 raised to minus 10 meter. So now you don't need to remember the frequency of X-rays. You just need to remember the radius, because we are already knowing that the radius of atom is 10 raised to minus 10 meter. So that will be the wavelength of X-rays. You can convert it to the frequency that comes out to be 1 angstrom around. Sorry, convert into the frequency that will give you the frequency range. But this 10 raised to minus 10 meter is basically 1 angstrom. And again, if you further decrease 10 raised to 10 ke baad, if you further going down 10 raised to minus 12 or minus 13 meter, okay, or sometimes minus 15 meter. So 10 raised to minus 15 is again very clear. That is the radius of nucleus. 10 raised to minus 15 meter is the radius of nucleus. So gamma rays can be easily identified with that. Okay, now you can convert it into the frequency. You will get to know the frequency of gamma rays. That is very high, of course, because frequency and wavelength, these are varying inversely. So if the wavelength is large, frequency is less. Wavelength is less, frequency is large. So that's perfectly fine. So by this way, we can decide the approximate ranges. And if you look at the scale carefully, there is a change of factor of 100 or 1000 in almost all cases. Most probably somewhere 100, somewhere 100 to 1000 scale you see. With that factor, the wavelength is going to be decreased, and accordingly your different regions are going to become in the electromagnetic spectrum. Now why we are focusing on this part? Because all these spectrum components we are going to study in your syllabus. Okay, so that's why at the time of lecture, when I say we are working with X-rays, so in your mind immediately it has to strike, okay, that X-ray, that means I am talking about the radius of atom. Okay, and again I am emphasize on that content that what range is here considered. See, if you here the thickness of hair comes out to be in the micro order. Okay, length can be large, no doubt, but we are looking at the thickness part, and generally this comes around into the micrometer range, hair thickness. Okay, so don't confuse with the hairs. You are not looking to the length, you are looking to the diameter. Okay, so that comes out to be in the micro size. I hope this electromagnetic spectrum part is clear to you, and that is very important. You note it down properly, you write down somewhere whenever you require, and at the time of lecture I may ask directly from you people. Okay, and then you must be ready with your answers. Okay, this is the range I am talking about. Fine. Based on that, what you can do is, as I said, okay, someone is asking what object can be compared with cosmic rays, right? So cosmic rays, you see the frequency is very high. Of course, the wavelength is going to be very less. In that case, nucleus case se bhi chota, then you may need to go for this, let's say, other nucleons which are there inside the nucleus. Most probably, right? There are many. If you go in nucleons, also there are various objects. Proton is there, right? Nucleon is there, and some other proton is also further divided into few categories. Okay, quarks, etc. So that all physics are there. But see, as I said, normally we are considering up to only 7 part. Cosmic rays are not included generally into the electromagnetic spectrum because that are okay. So what you can do is, your task is this first problem or statement already you know. So now you need to write all the spectrum component in a sequence depending on you आप कैसे लिखते हो, either in terms of wavelength or, but try to write in both wavelength as well as frequency, and choose a particular scale, increasing or decreasing scale depending on that. But keep in mind the scale has to be uniform. Either you write in meter if it is wavelength, or you write into the frequency, I mean you write into the hertz if it is a frequency. Okay, so that two scale only you need to follow uniformly, so your answer may be perfect every time. Okay, now coming to the next one. I hope this first problem statement is clear to you. I have solved it properly. Now coming to the second one, the second problem statement. Yes, you can consider as an assignment. Okay, this is your tutorials problem. So it will be good if you prepare a separate notebook and do the activity of this tutorial in one single notebook. Okay. So what you can do is if possible from your side, then you just take a notebook, and in the first half you can consider for lectures, and for the second half you can consider for tutorial related object. Okay, for visible, yes. So for visible you can consider, see, the for visible the range is 10 raised to minus 6 meter. So basically all this protozoa or jo bacteria, all this related stuff you can consider for visible. Yes, bacteria, protozoa, these can be considered for visible. For UV, molecule is there. Cosmic rays, even more than that, right? Oh, okay, these are the 10 raised to minus 12 to 14 wavelength. Fine, but if you look at the energy wise, because cosmic rays, I remember in terms of energy, because I was working in the energy range only in my research time in the TIFR. I was dealing mainly with the cosmic rays. So these cosmic rays are having very high energy. If I talk about in terms of frequency, then it is around 10 raised to 16 to 10 raised to 18 hertz, even more than that. Okay. Uh, Now the next problem statement, that is determine the energy. If you people want to write, then you can write it. Determine the energy in electron volt corresponding to each part of electromagnetic spectrum. See, these particular ranges you can decide it, because I told you the frequency of this, right? I told you the wavelength also, that gamma rays generally belonging to 10 raised to minus 12 to minus 15. That's perfectly fine in meter. That is wavelength. And frequency you can convert according to this. You can make a separate notebook if possible. Otherwise, what you can do is you can prepare a notebook in which in first half you can write about the lecture content. In the second, you can write about this tutorial part. Okay. Second number of problem statement I am speaking again. Determine the energy in electron volt corresponding to each part of electromagnetic spectrum. Okay, so now you see, as I told you, if you are following the systematic approach, then already you have a scale properly either in increasing order or decreasing order. So easily you can find out the energy and write down into the respective columns, right? Yes, using this formula E equal to hf or h nu, and since you are having the frequency, so you can calculate. If you are having the wavelength, then sc upon lambda, that will give you the energy of that. Now important thing is your answer and their scale. Okay, you people might be getting the answer somewhere sometimes in joule, but you need to convert into the electron volt. I think from this you will get the answer in joule. Okay, and then later on you need to convert into the electron volt, because your normally we are asking the energy in terms of electron volt. I am repeating again. Sorry. Determine the energy in electron volt corresponding to each part of electromagnetic spectrum. Okay, so you have that spectrum ready with you people. You just need to convert using the formula. If you are having frequency E equal to h nu, if not, then E equal to sc upon lambda. That will give you the answer in joule. I have asked the answer in terms of electron volt, so you need to convert it, and now you know very well how to convert from joule to electron volt. You need to divide with that 1.6 factor also you have to include. Okay, so I hope this second problem statement you can be able to solve it. You are able to solve it, right? So I'm leaving it to you people. Yes, charge of an electron, correct. That's perfect. So you will get your answer in electron volt. Now comes the third problem statement, and I think we have already covered that, but still let me say it for you people. The third problem statement is give the examples of different objects with respect to their comparable wavelength in electromagnetic spectrum. So I think we have discussed in a proper manner, right? Already we have discussed about the components which are existing to belonging to the that range. So the third problem statement can also be fulfilled with this. So you can write whatever the examples we have discussed, you can write to this problem. That is, I am again repeating the problem number 3. Give the examples of different objects with respect to their comparable wavelength in electromagnetic spectrum. I am again repeating the problem number 3. Give the examples of different objects with respect to their comparable wavelength in electromagnetic spectrum. Okay, so now you know the answers. Okay, so you can write into that. Now the fourth part, the fourth problem statement, discuss the importance. Discuss the fourth problem statement is discuss the importance and use of various parts of spectrum in our daily life. Now this particular problem statement we have covered little bit, but still we need to explore it more. So let's discuss this time. Okay, I am repeating the statement, problem statement number 4. Discuss the importance and use of various parts of spectrum in our daily life. Okay, so I think importance, can anyone deny the importance of any object, any component? Feel free to discuss, because now we have only 10 to 12 minutes, so you can unmute yourself, and if you want to discuss something, then let's discuss. Can anyone deny the use of any of the component of electromagnetic spectrum?
No, sir. Every component is useful in our daily life.
Yes, correct. Now it is very clear that everything is required in our daily life. Then where we need to identify the area, right? Where can be used? So let's start with one by one. Radio waves,
FM.
FM radio, correct. The signals which we are transmitting from one place to the another. So that is basically radio waves. Yes, communication में. Now coming to the next, which is micro.
Oven. Oven.
Microwave
ओवन में,
oven.
yes, माइक्रोवेव ओवन है, फाइन.
Radio.
नेक्स्ट,
Radio. Radars.
रडार में, फाइन, रडार में भी होता है, करेक्ट.
फायर बॉल की स्पीड चेक करने में.
किसकी स्पीड?
बॉल क्रिकेट
बॉल
में
की
ball.
स्पीड. ओके ओके, फाइन. नेक्स्ट, इंफ्रारेड.
TV remotes.
यस, सेंसर में, राइट.
Thermal imaging.
थर्मल इमेजिंग, परफेक्ट. So these are all
To
the,
identify weather.
okay, so these all are the practical examples which you are seeing in your daily life. Okay, visible, of course, without which we cannot see,
Yes, sir.
right? So visible तो जरूरी है ही, otherwise nothing will be brightful. Next is UV,
Welding.
welding में.
X-rays. Medical
हाँ, but okay, medical. What other purpose, other areas of UV?
Eye
Industrial.
surgery. Eye surgery.
Eye surgery और treatment, water treatment, UV related,
हाँ.
UV RO
RO. Water treatment.
है ना, UV treatment होता है, water treatment.
Yes, sir. Absolutely.
And then you may have some UV protected glass, right? So there we are protecting the UVs, but still that device, some devices which we can use to protect these UVs, and somewhere we are using the direct UV signals. Apart from that, X-rays,
Medical purpose.
medical. Then
to examine size and radius of atoms and all, study of atoms.
yes, correct. Because as I
Sir,
talked in the first lecture, na, physics of nanomaterials. So there we are going to use the X-rays, and that X-ray can be useful apart from the medical purpose. X-rays can also be useful to find out the structure-related properties.
Sir, X-rays can also be useful for finding cracks in
Yes.
big containers.
Yes, that's possible. Fine. So X-rays are also very important. Even if fracture is there, then of course we need to take the X-ray. Then only we'll come to know what is the exact problem. So these all are really important for our life. Another is gamma rays.
It is used in radiotherapy to kill cancerous
Yes,
cells.
yes,
Reactors,
radiotherapy. Yes,
nuclear
correct.
reactors.
Nuclear reactors, of course. If you want to find out some unknown particles, okay, then again we need to go for the gamma ray sources. So that's completely perfect. So all these areas are equally important for us. Okay, so we cannot skip anyone out of that. So these are the things, practical areas where we can apply this. Fine. If till this moment, if anyone is having any doubt in understanding, now you can talk about the lecture part also. If something you want to ask during the time, if you have missed it, now you can ask it related to both. Any doubt, any query so far? Anyone? Everything is clear? So someone is asking for the tutorial side. So these are the questions for tutorial only. I am taking from the tutorial number 1. That's it. And sometimes you may get numericals also, no doubt. But this time the first one is the prerequisite, so it's kind of little bit theoretical, not the practical side. But practical we have made it right. We have just compared with the surroundings and have given the proper examples to understand these things. In exam it will be the same way, more or less, yes. But you also know very well whatever we are saying something, it cannot come as it is, right? There may be slight changes. Radio waves in meters, 1 to 100 meter, I told you 1 to 100 meter is the range of radio waves. See, at this moment, if I consider now someone is asking, do we need to show them in the notebook? So it is up to you people, right? How much you are going to satisfy with yourself. So if you think that if you don't want to write, it is up to you. But normally it's a good way you keep a proper record so that at the end of the exam or at the time of exam, you may get all the systematic data properly with you people already arranged. Otherwise, you need to look here and there for the content. Okay, checking part, as far as it is not like a school level system where I go to your things and check it properly whether you've done it or not. No one is going to worry about it, but it depends. It depends on time to time, but normally we are not, at least I am not following that methodology. Okay, so if you believe, then you can write it, arrange it in a proper sequence that is going to help you people only again. Okay, but there is no forcefully stuff like you have to do that, this is the mandatory or something. That is not kind of the stuff. Even if you're not going to prepare any lecture notes or something, that is absolutely right, that is completely your choice. But if you are preparing something, then they may be helpful for you, that content may be helpful for you in the higher stage. Okay, any other? Yes, this recorded lecture will be there. Already it is going to be recorded. Okay. So maybe after completing this lecture, you may receive the recordings. So you can. See, again, I am saying I am not going to check a tutorial book, but it is expected in Nirma at least that you please maintain a proper thing, right? If you are doing the tutorial, then you please arrange in a proper sequence so that at the last stage, you are only the sole benefit of the activities which you have performed in the last time. Otherwise, it's very, very difficult because you need to jump here and there. Okay, so since you are having time, you can write it down. When you think that there is no time or something, that time you can skip. Otherwise, it's a good practice that you follow the trend. You write down the required component, required details in a proper sequence. Attendance already it is going to be recorded. It's live. Okay, so any other thing, attendance? Yes, 85% attendance is mandatory. You might have heard in the orientation program also. So try to, I mean, this physics lecture cannot be boring. I hope so, right? Because we are making it so much fun. Okay, with lot of examples. And I all believe that rather than going here and there, you just listen to the content properly, and everything will be crystal clear to you people. You don't need to look even after the class also. Okay, maybe just do a quick revision whenever your exams are going to come. That's it. Otherwise, no need to learn extra. If you are really interested in some learning extra stuff, then only you can go further. Otherwise, this class content is itself very enough for you people. I hope you guys have enjoyed it a lot, right? Okay, perfect, perfect. Uh, Someone is asking for the tutorial side, so let me tell you that tutorial. I mean, this checking part is not having any marks, but some activity or some assignment may be given related to the lectures or maybe tutorials, and that have marks rather than tutorial directly. Okay. Another thing is, feel free to contact me on my email ID. I think one of you, roll number 151, if I remember correctly, then he was worried about the lecture content, that he hasn't received any link or something. Then I told him that don't need to worry, you will get the link, because see, if I send the link earlier, then it might get misplaced, right? Sometimes there are so many emails you may have received or you are going to receive in future, so it may be very difficult you people to identify at the last moment. So that is why uh, I have sent it to just 15 to 20 minutes before to the actual things. Okay, so someone is asking for the difference between the tutorial and the regular class. So tutorial is basically it will provide you the thought place, right, where you can think about certain problem in a systematic arrangement. As I said again on the word, how to solve a problem in a proper sequence with proper logic. That part we are going to cover in tutorial. In regular class, we are just discussing the theory, principle, and other stuff. That's it. But tutorial will give you more freedom, more thing to explore in terms of numerical, in terms of some different thinking. So that part can be possible in the tutorial. Okay. Apart from that, any doubt is there, then you can just contact me on the email ID. Okay, I will be able to answer. And I also suggest you to wait for 1 week, because in the meantime you will get all the study related documents. And still, if you are interested in some learning, then I have given you the YouTube link. There you can go and explore more about the laser physics, which we are going to cover in the next lecture. And it is also equally good for me also if you are coming with some preparation, right? Already if you are reading some content and then coming with, then directly you can ask your queries. So that is a win-win case for both of us. But if you're not looking to the content, that's also fine. We can cover into the class. The only requirement from my side is you need to be attentive during your lecture. That's it. And I'm not expecting you people to go out and after this class also you need to study something. Nothing. You just focus on the class content. That's it. That is perfect.